All right, let's begin. Want to start with 400? Let's start with 400. Minimum stack. All right. Design a stack that supports push, pop, and top to retrieve the minimum elements in consistent time. Okay, so I have to do push, pop, and whatever. So we will do. Are they supported? Or we could Java 8. It doesn't matter. Push, pop, and whatever. So we have to do a linked list stack. Stack is what? First in, last out. Alright. We know stack is first in, last out. And I should have taken this class. I actually missed this class, to be honest. Like I was not there for the full time. So how do you do first in, last out? So you need to first declare a node, okay? That's gonna be pretty much okay. Retrieve the minimum and constant time. 1 second, let me just check something. Minimum elements. Retrieve the minimum elements in the stack. Okay, push 1, 2, minus 2, get minimum. So push 1 minus 2. Yeah, so we get push 1, push 2, push minus 2. So 1, so we should get 1, oops. So 1, 2, minus 2. Get min should be 3. Oh, get the minimum element in a stack. Okay. Maybe I should have taken the class. The attendance of the class 40.62%. Yikes, I did a huge mistake in judgment. Alright. Alright, how do we do stack? So what does a stack have? Stack has information and an address. It's a node. Right? I'm pretty sure it's a node. So once we go ahead and push another one to the stack. So we have got I'm not confident of this one, which is sad because I know what I'm doing. So the last will be here, which will be okay. Does not have anything. Push. Okay, push, push, push. So push will mean that this pointing to next will be the first node. This will point to null. So the address always points to previous. This is the info. So we previous. So we know that previous points to this, and then this. Okay, so we should be good. All right. So let's go ahead and create a class. Class node where we have int val node previous. All right. So now let's create a node called start. Okay, actually, you know what? Let's actually design this. Let's actually fucking design this. Okay, how will we design this class? What does this class have? Okay, it has value and previous. Okay, so this previous, so for push, what will we do? Okay, do we have a global variable declared which is node start is equal to null? Yes. Or no, top. So we'll create a top. So above has create a top. We'll have to have a top. Okay. Minimum value. How do we get the minimum value from a stack?
If I had money, I'd buy those people a place to stay. If I had money, I'd buy those people a place to stay. But all I got is a dime, and I got so little time.
So we can also have a minimum element just here in the stack.
If I had faith,
But here is the problem with that. Will it be a static int? I think it'll be a static int because here is the thing. You cannot create multiple instances of that,
on my knees,
right? Once an instance is created, you can go ahead and check that anytime you want, and you're good. And that's the way to do it.
if I had faith,
Close Outlook.
I'd
Jesus
get
Christ.
down.
Okay, you know what? Let's not think too much about it. Okay, let's just have a static int outside. All right, which the static, not static int, just an int in the class. Okay, with this int we'll keep track of the minimum element. All right, got that? Let's just do that. All right, outside the integer minimum stack, push if top is equal to null, then just we'll just say, hey, it's equal to new node of type element, where next is equal to null. So what we can do is, of course, let's just define a constructor. I need to be a bit more confident, man. I need to start exercising more, I guess. Okay, let's create a constructor node where we take an int v. What we will do in this int v, we will go ahead and assign val is equal to v, previous is equal to null. But we're trying to give a value, right? So we're trying to give it a previous value equal to node pre. Okay, simple as that. Alright, so we're gonna go ahead and create a node which will basically have a previous null etc to it, where we'll just pass a null if it's the first element. Simple, because the bottom is always pointing to null, the stack is empty, we're good. Okay, so what will we do? We will create an int min which will be equal to integer dot max integer dot max underscore value. Alright, so we've got an integer dot max value here. We will create a node top is equal to null. Simple. Now how do we push? The push will be pretty simple. Push will be if top is equal to null. If top is equal to null, then new node top is equal to new node um, x comma null. Okay, else what do we need? Else is pretty simple again. um, oh, we forgot one thing. We can just, do we need to even check if top is equal to null? That means there's no min value. Min is equal to x. Okay. Get min. What will get min be? That means get min will be return min. Simple. We're good. All right. Okay. What is else over here? Else. We need to now add to the top of the list. How will we add to the top of the list? Else. Let's take a node, and new node is equal to new node of type x comma top. X comma top. So now the top becomes the. So now previous has assigned the value top, which is fun, and then the values are the new node is assigned the value of x. So top dot previous. Okay, so what happens here? Push. Okay, so now we defined a new node. So top right now is pointing to. So top right now is this node. Okay, there's a node with value assigned of null and a value with the address 10.10. Okay, now we created a new node which has the top's address, and now we need to make this new node as the top. So we need to go to the top is equal to new node. Simple, good, works. We don't know if it works yet, but now, okay, now what else do we have to take in consideration? We have to take in consideration min min is equal to math dot min of x comma min. Alright, this should manage the math dot min situation where it's like, hey, if that's the min value, then we're good. I don't know what's going on. Okay, we've got push, we've got pop. Am I allowed to make another class in a class though? Let's just test that out. Okay, I'm missing a return statement. And what am I missing? Oh, top. Top? Oh, I have to return top dot value. Okay. Return top dot value. Is that it? Top dot val. Yep. So we should be able to return top dot val. This should be simple enough. Again. Yeah, I just don't want the trivial case to be correct. Your function returns so. Yeah, because I've not implemented pop yet. Because we ain't popping. Okay. Push. This should be fine for push. I think this is completely fine. No issue whatsoever here. Let's decide popping. So how do we pop an element? Pop an element would mean I don't need to delete anything in Java. We have to delete in C++, but not in Java. So I'm pretty sure we're good. I think I'll do all of these questions again in lead code when I get to it, because I do want to get good at C++. But because we are in the concept of scalar, I think I'll do that later. But now let's do the popping mechanism. So say this is a top. This is a previous. Okay, this is the top. Now all I have to do is top pointing to, so top is equal to top pointing to previous, and once top becomes a previous node it's popped. All right. What are the conditions that I'm missing? All right. So say if top is equal to null, what do I have to do? Is there a condition? Pop should return nothing if the stack is empty. So return is fine. Else we can just go ahead and say, hey, I just realized my issue. I do not know what the minimum element would be if we return the top. I will need help in this. I cannot believe I'm saying this, but I'll need help in this because I do not know how to go ahead and say, hey, now the minimum element, if say the top has the minimum element, what becomes the minimum element? There can be another minimum element somewhere in the system, right? Like, that makes zero sense.
Stop treating me wrong. Cold-hearted woman. Stop treating me wrong. It's a pity.
Okay.
Low down.
Let's just go ahead and let's write everything else first. Okay, we know if top is equal to null, return nothing. Else we can go ahead and now here is where we have to write something that makes sense. We know. Okay. So do we have to actually put a minimum over here in the stack?
How can a poor man make it? I said when money is the name of the game.
Should I?
Used to have the best credit
Should I put a
every
int
place
min
in town.
in this and save the minimum as well at each stack? So
No money
I can
down.
just return
Things done got tough, y'all.
top dot min. Does that make sense?
Now my name won't even buy me
Like I can just take
some bubble gum. It's a pity. Low down.
I can just take this.
Tell me how can a poor man make it? I said when money is the name of the game.
I can just write it here, right? Whenever I'm making a new node, and then just calculate it here, and I can go like, yo, if we can just go min is equal to math dot min of previous dot min p dot min comma v this is so jugado. I am not even freaking okay. I'm just this is so this is so jugado. Okay, so that means every time I create a new node, what I will do is I will have a minimum value here, right? It will go ahead and check if the previous is not null. Okay, and then in the previous it will check. Okay, if okay, and I can even put an else condition here. Yo, I'm doing this all in a freakish constructor. That is dummy because that means I have to write no more code because it'll go like, hey, that means you're definitely at the top. If you're not at the top, so that means hey, just do math.min previous.min.v, check which is minimum, keep that minimum, and you can just return the whatever is at the top of the stacks minimum. You can go ahead and push dot x. Okay, good. Null. Okay, you got null. You got minimum is equal to x. This is so jugado. Because I still have to change none of the code. I can just go ahead and say, hey, if top is equal to null, then just push a new top with a null as a previous. And if previous is equal to null, then, and in this case, previous will not be equal to null. In the next case, it'll just go ahead and keep checking what is the minimum value. Don't even need to do this anymore because it's just doing it here. It'll assign the v as the min. That is beautiful. I don't see it. I see this as a win because what does it mean? It means I can push things out of the stack without having to reduce, without having to like actually do crap, right? Okay, what is pop over here then? I wrote the code for pop, right? Why do I get this stuff while I'm coding? I don't know why. Okay, pop. Alright, what do I have to do for pop? Pop, I have to go ahead, this is the address. So if top is equal to none, return nothing. If top exists, if top dot previous is not equal to null, if top dot previous is equal to null, then just simply top is equal to null. Alright, let's do that. Simple. You're pushing. If top dot previous is equal to null, that means there's nothing before. Just do top is equal to null. Okay. If now we can go else. So we can go if else. In else we can just go ahead and say top top is equal to top dot previous. Simple. Okay.
Black as night, cold as ice. She left me. She didn't think twice. I tried to stop her.
Alright, what do we have? Now, top is equal to return. Top dot previous equal to null. Top is equal to null. Leave. Doesn't matter. Else, top previous equal to top. Okay, so what do we have? Why was I thinking so much about this? Alright, so we've got minimum value. So what will this do? It'll create a minimum value on a stack. Cool. Now we go ahead and push top is equal to null. Push top, blah blah blah. Node dot top. Okay, fine, good. Push will pop will do that. Top into top will return the top value. That's not what it wants, not top value. Top returns 2 as that's the topmost element. Cool. Okay, let's test this. Oh. Okay, -1, sorry. That makes sense. Fine. -1. -1. Okay. Yep, that works. Ladies and gentlemen, that was the dumbest thing I've done, and it's funny as hell. And I'm saying that before checking if the code works, and that's never something to do. The code works. That's 400 points, ladies and gentlemen, for being absolutely stupid. 27 minutes. I'm down. That's good. Given a string A consists of open bracket and close bracket, you need to find whether parentheses in A is balanced or not. If the balance, then return 1. So what does that mean? Oh, for every opening bracket there should be a close bracket. Okay, how do I do this? Okay, this is a stack problem. So can I just do it with counts actually? Let's see this. Okay. So if quote open bracket quote close count plus else if what will be the inputs constraints problem constraints A will be a modulus, so it can only contain these values, so I don't need to worry about things. So let's just say else count minus. Okay, if count is equal to 0, balanced. If count is not, else unbalanced. How about that? Can we do that? Let's see expected output for an open close. This is balanced just for the sake of it. So I cannot do that. Okay. Okay. So every open bracket should have a closed bracket. Not the other way around. So it's going rightwards. Okay. Oh yeah, but in my case also, if I do count minus, So it'll be count 2, 2. Okay, how about open bracket, closed, open, closed. Okay, for every open bracket there should be. Okay, so what we can do is count plus plus. If we can still do count plus plus, because that would mean we can still use the counting technique where we are pushing the count on to the thingy. So if quote unquote bracket is open, let's say it starts with an open bracket, but then it's for every open bracket there should be a closed bracket. So only then it is balanced, because I cannot do this. This is not balanced. Yeah. Alright, so then it's pretty easy. Like if count is less than 0, just return 0 when it's trying to close, or else count minus minus. So we can do if quote unquote open bracket count plus plus, else if count is less than or equal to 0, return 0, else count minus minus. And in the end, if count is equal to 0, return 1. Count is not equal to 0, return 0. Count if else, return 1. Okay, perfect. This is the logic I'm going for. How do we do this? So we get int n is equal to a dot length, which is a function for some reason. For int I is equal to 0, I is less than n, I plus plus 10 to the power of 5 modulus. I can do this in an n order. So if a dot correct at I is equal to quote unquote open bracket, we need to start with int count is 0, count plus plus, else if count is less than or equal to 0, return 0, else count minus minus, and then once we're done with the for loop, if count is not equal to 0, return 0, return 1. Alright, what does this do? We just go to the count, we go ahead and push to the stack saying count plus 1, count minus 1, blah blah blah. Okay. Yep, there we go. Perfecto. Pure perfection. This was easier than I thought. Holy crap. Now I can actually go to the difficult one. Oh no, I'm so scared. Actually, let's see the solution for this. Because I don't know why this was given in stacks. I think this was just to explain how stacks work. Let's look at the complete solution by them. I'm hoping there was, yeah, they did use a stack. They used literally the data type stack. What? No. Yo, I should have watched the class because that would have made shit easier. Holy shit. Did they use stack for the earlier one? There's no way, right? There is no way. Fuck you, C++. Java actually. Complete. They use a minimum stack. They use an integer. Why can't stack is an extendable k-type template? Why didn't they just use an integer comma integer? That's insane to me. That is just insane to me. I like my own stack better then because I can just put a function there and have it assigned based on that. I'm pretty sure we can override. Oh god, that's crazy to me. I just wrote my own stack. I like my own stack. My own stack does my shit properly, automatically. Yo, this is crazy. This is fucking crazy though. Oh no, this question. I'm gonna suck at this question. I'm bad with the recursion. And I said that for like even bitwise operations and then I got better at them, but oh no. Oh no. Given row and index B, return the bth index with the symbol of the row. The constraints might have a what do you call this? What do you call this? An example? It's no, a clue. Okay, but let's see what's going on. On the first row, we write a 0. Now, in every subsequent row, we look at the previous row and replace the occurrence of zeros with a 0 1. In each occurrence of 1, we do it a 1 0. In a given row index, return the bth index symbol in a row A. The fuck are you talking about? What is this? The values of B are for one index. Okay, so that means it stops at 1, starts at 1. So that means even, okay, so the reason why they said one index, that means if n is equal to 1, our recursion should stop because the topic is recursion. That is example 1. Okay, A can be 20 and B can be 2 to the power of A minus 1. Holy shit. That means 2 to the power of 19. Do I need to do this in a log n? Yo, that's insane. Okay. Let's try and do this in log n. Okay. First argument, integer A. Second argument, integer B. Returns donates bth index symbol on row A. 2, 1, 0. Row 1, row 2. I'm gonna ask for help for this one for sure because I don't even understand the question. Two. Does it mean the grayscale? Is that possible? Because it looks like that. The row 1 for a grayscale is also 0, 1. Am I crazy? 1 second. Yeah. See, 0, 1. That means that if let's just take 1 and 2 index. 1 and 2 index of the 1 and 2 index of 3. I think we can just take the output like that. So let's just take that. So say if the first input is A is equal to 2 and line 1, line 2. Okay, line 1, line 2. So we can take 2. We can take 3 and 1, 3 and 2. Okay, let's see if 3 and 1. So this should be equal to 1. 1, 2, 3. I'm so stupid. Row 1 is 0, row 2 is 1, row 3 is 3. Okay, how about this? Let's try this again. 0, 1, 3. Okay? 3. Cool? 3. Okay, so we have to put in the fourth row. 1, 2, 3. No. Row 1, 0. Row 2 is 1. One, two. Okay, what is 4, 1? 4, 2. Okay. Okay, so I don't understand the question. Good to know. Good to know. A given row, okay, in a row, each occurrence of 0 is replaced by 0, 1. Each occurrence of 1 is replaced by 1, 0. Let's look at the sequence then. 0, 0 is replaced by 0, 1. In this one, it will become 0, 1, 1, 0. This will become 0, 1. This will become 0, 0, 1. 1, 0, 1, 0, 0, 1. Then, so A can only be 20, so we can have up to 20 rows. So let's look at till 5. What's the reason? 0, this will be 1, 2, 4, 4, 5, 6, 1, 4, 6, 8, 32, 64. 64, okay. Yeah, so this is arbitrary, it doesn't make sense. But what does here? Okay, let's look at it this way. 0 becomes 0, 1. 0 becomes 0, 1. This becomes 1, 0. Okay? 2. This becomes 0, 1. 1, 0, 1, 0. Sorry. 1, 0, 0, 1. So how can I go in a fashion where say I get this number because we have to go up to 20. Okay, that's the maximum we can go. We can go up to 20 recursions. Alright. So what I can do is I can use a bitwise operator for and see if so 1 and 1 is equal to 0. 1 and 0 is equal to 1. That does not work. No, it does. Return 1 and 1. Wait, what? 1 and 1 is equal to 1, right? Yeah. 1 and 1 is equal to 1. What's wrong with me? Okay, so we can go ahead and say, hey, listen, we know the B is the index. So I left shift B and uh, N, whatever the N is equal to what we want. Alright, but how do we get there? So we know this recursion functions end goal is to reach B, so is equal to where, so the A is the row where A is equal to 0. So return 0. Okay, so what is the condition that will cause it to go into recursion? The consideration would be A minus 1, because if the row is fifth row, this is crazy. I need to practice much more recursion, man. I need to practice way more recursion because this is entirely crazy. Because if this is not a problem that should give me an effortable issue, because we are just simply reaching I is equal to 0. All we have to do is um, I'm literally sure that the answer is some return b minus 1, sorry, b minus 1 n left shift. Okay, what is happening in binary over here? Uh, we are left shifting 1 times, adding 1 here. What about here? Are we right shifting though? That's my question. Is it possible this to here is a right shift? 1 2 4 0 2 4 8. So this becomes 8 bits. So it is increasing in 2 4 8 16 32. Okay, so that means this is where the login approach can kind of go towards. We know that. Alright. So how do we get it to that? You know what? It's no shame. Let's just ask for help. This one is a bit tricky for me. This is a bit weird and irritating. That's a guitar and a half though. Okay, what do I know till now? What do I know till now? Let's see. Um, cannot breathe anymore. That's insane. Mm, got no bees. All right.
Hello.
Hey, Anmol, how's it going?
Yeah, it's fine going. Hi, Jabir. Yeah. So what's the issue?
Yeah, I am not able to figure this sum out. Um, so this is just getting the kth symbol. Um, okay, so I all I know is the progression is happening on to the power of n
Mm-hmm.
basis. Like this is where I'm. So I've not written any code as of yet. Okay.
Okay, okay, yeah, sure.
So I'm just telling you where I'm at in my thought process because I'm hoping that I'm at least a bit close. So I know the progression is happening on the 2 to the power of n. The recursion is supposed to end when a is equal to 0. All right.
Yeah, definitely. Huh.
Um, Now to call this, that means now I have to at some point return uh, the number and uh, one left shift b. Okay. This I
Mm,
know that the ending condition I need to get this where the
okay.
n is the number on the like
Basically, what you can even return here is like kth symbol, like was some kind of k value in the recursive function, and like suppose you are given n rows, right?
yes.
This is you are given a rows, so you can return a minus one there. Matlab, you can call recursively with a minus one and some k. So that
So
will be your recursive function in
so
that way.
a is the maximum number of rows it can have. Okay.
Hmm. Yeah.
The b is the index. So
Hmm.
do I need to create a helper function like for grayscale code where I basically go ahead and say um, public int
Definitely. You need to
case
have a separate function. You can't
symbol
like you shouldn't do inside the solve. You
num
can have that function.
comma b,
Hmm.
right?
Yeah.
Okay, comma int b, where I have a number defined beforehand. Okay, so this is where I'm stuck.
Hmm.
All I know is if num is equal to 0,
Then you
return
need to return 0.
0. All
Hmm.
right.
Yeah.
Then what do you call this? Then I have to go ahead and say num is equal to I think something like case symbol num minus 1 comma b. I don't know why I'm
Hmm.
sending b actually.
Yeah, you should send B in the way ki, like if you are at a nth row, okay.
Mm-hmm.
So that row you can divide it into two parts, okay.
Mm-hmm.
The left part would be the exact copy of that previous row. If
Oh,
you,
oh, so
yeah,
it'll be mirror images.
huh. That the left part would be the exact copy of the previous one. The right part would be the like you can say the inversion, मतलब basically that invert bits. So you
I
mirror
did not even
whatever
notice
you
that. So
say.
that means 0. So only thing is if it's 0, it'll become 1 0.
Hmm.
Um,
Then again 0 1, then 1 0.
from
मतलब,
here it will become 0 1 1 0.
yeah.
Then it'll become
Then
0 1
again
1
one 1
1
0
0
0 and 1 0
0.
0 1. No, no, 1 0 0 1.
Why 1001?
मतलब it should be the inversion of 0 1 1 0, right?
Yeah, so it'll be 0 1 1 0 or
And
1 0 1.
0 1.
So it'll be 1 1 0
No,
0
no, 0 1 1 0 should it would be 1 0 0 1.
1 0 0 1. Yeah, sorry. So
Yeah.
it'll be reverse of this.
Hmm.
So we can divide that into a left and a
So
right. So let's say we are
yeah.
only getting left.
Hmm.
And okay, I'm still confused. I am still confused. I'm very sorry to say.
So
I can.
देखो, actually, like what would the answer? Either 0 or 1, right?
Yep.
So if you are on the left part of the string every time,
Mm-hmm.
so your answer would remain as it is. But if you are on the right part of the string, it
There'll
would
be two
reverse.
times, yeah, two times
Yeah.
n or one.
So basically, like it would revert if you are on the left right string, but it would
Mm-hmm.
remain same if you are on the left string. For so for every string, you just need to check ki the current kth value is
Mhm.
greater than the mid of the string or not. If it's greater than the mid of the string, then you need to process the rest of the operations on the right side. And if it's less than the mid of the string, then you need to process all the other operations on the left side.
Okay.
Suppose right now the string length is 8. Okay.
Yeah.
If I ask you to process sixth symbol,
Okay.
so what you can do is you can take out the right part of the string. That means you will have length 4. Okay.
Mhm.
And for the sixth symbol, what you can do, you can subtract that length 4 there. So 6 minus 4 is 2. So basically in that right part of the string, it would be the second symbol.
Yeah, I get it. I get the point. I get the point of dividing it to left. But it's like binary search, but only thing is you already
Yeah,
know
divide and
once. Yeah,
basically,
divide and conquer. Okay. Yeah, that's something I got from a to the power of -1 for sure. It's just writing the code is being difficult for me because I'm not able to come up with how. So recursive. Okay, so earlier I was bad with binary. Now I'm bad with recursions. So so I'm just trying to figure out how, so this is like two of them combined together, which I like two exercises that I need help with. All right.
hmm.
So I have, okay, so it'll end at 0. 0 will then I return. So we know that if in this case num is
Mm-hmm.
equal to 0, we go ahead and return 0. Okay.
Yeah,
If b is
is
greater
greater than,
than
then you can have that separate variable c to be 2 to the power n minus 1.
okay, we need to have a separate c.
Yeah, matlab basically to compare the values, you can have store that value na 2 to the
Yeah.
power n minus 1 there.
So where do I store that value?
In any variable you can store, like every time you'll have to calculate 2 to the power n minus 1, right?
Oh yeah, yeah.
Hmm.
So I'll have to calculate. So
No,
let's say,
it's not just key you need to pre-calculate. You can directly calculate using power function as well, because the a value is 20 only.
but it'll be better to just store it, right?
For memory
So like
efficiency or in terms
B,
of
so like
speed and
the,
time.
so we can, okay, sorry. So we can just simply go ahead and say int c is equal to math dot pow b, sorry,
2 to the power
2
n minus
comma
1.
b minus 1.
Yeah.
All right.
Hmm.
So we'll have to always calculate this.
Let that line be written in line number 8 only, which the recursive function would be the kth symbol. No?
Yep.
So let this line be inside this loop only.
Yeah. All right. Now we also know if num is equal to 0, we go ahead and return 0. Um, so we go ahead and if uh, b, no wait, shit, b is greater than c,
Let it be greater than equal. Achha, let it be greater than. It would be correct. Greater than always.
then we're
So if
gonna
b is
add
greater than c, then b equals to b minus c by 2.
b is equal to b minus c by 2.
Yeah.
Okay. All right. We've got that.
Now you can store answer. Like you can store some kind of variable answer. Let's have after line number uh, 17. Int answer equals to kth symbol num minus 1 comma b.
mm-hmm,
And what you need to store is, acha, let's call this symbol inside this 16 line. Like let's directly return the value from here. What you say, can we remove
oh,
that answer? We
yeah,
can
yeah, yeah.
directly use return statement as well. Return k symbol,
Yeah.
return in not of k symbol, basically return not of k symbol. क्योंकि now we are on the right part.
Okay.
Like if b greater than c, I want you to write this line inside b greater than c.
Oh, okay, got it. Um,
And else just you need to return kth symbol num minus 1 b.
okay. This can be also written in one line now that I think about it.
Just remove that not sign from here.
Yeah, yeah, sorry.
Now I think it would work fine.
Um, Okay, I'm
With,
yeah. So
uh,
sorry, Kate. I know I have to just call Kate symbol a comma b.
B, and you can just return from there as well.
Yeah.
Return case symbol. Yeah.
Okay. No, yeah. I'm sorry. I think, but this all could be done in one line, isn't it? Like, okay,
Yeah,
we could have done it here as well, right?
yeah, we could done that there as well. Yeah, sure. Like after that, maybe if it works fine, then you can try to merge it into the solve function as well.
Yeah, I'm just trying to comprehend this again. Why did I miss this again? Okay, so see, what are we doing here? We are doing basically, why are we reducing b with this complete?
We are reducing here because now we are concentrated into a right side of the string, not on the left side.
Okay, so
Just I ask you, कि suppose current length is 8, right?
okay, so let's say, current length is 8. Okay,
But
row is say, wait,
so this
just
8
give
would
me an
have
a,
been,
what is a equal to over here? The row is equal to say 2, 4, 6, 8. Okay, row is equal to 4. Okay,
yeah.
b is equal to 5. Okay.
Hmm.
So this will basically go ahead and say, because we know b is equal to 5, that will be 2 to the power of 2 minus, sorry. So that means it
For
is,
a equal to 4,
yeah,
it would like there would be 8 like characters, right?
yeah, so it'll be 2 to the power of 3 minus 1, right?
2 to the 4 minus 1,
To the power of 4 minus, yeah, so 2 to the power of 4
3.
minus 1. Yeah,
Like if there are 4 rows, then on the last row there would be 8 characters, right? It
yes,
would be a string of 8
2,
length.
4, 8, yeah.
Hmm.
So 2 to the power of, so we are taking c is equal to uh, 8, which is equal to 2 to the power of 4 minus 1.
Hmm.
Okay, so now if you're doing that, that means so we are trying to get the fifth digit. So we know b is greater than greater than 2 to the power of 4. No, b is less than that.
What? I didn't get you.
So b, we are saying is b
Like
greater than.
B, like 8, basically you need to find a fifth symbol, right?
Yep.
So you are using C directly here. It should be C by 2.
Oh, okay.
In
Yeah.
in line number 14th also you should use C by 2.
Yeah, only in
Hmm.
line number 14, right? So what we are
Yeah, yeah.
doing over here is because okay,
Hmm.
so in the first recursion, we can say that um, C because B is equal to 5,
Hmm.
right?
Hmm. Hmm.
So it'll go into else. It'll call the kth symbol again, where A will become 3, right?
Yeah.
3, and then uh, B will stay the same, and then we can keep on reducing till we find 0 or 1.
Hmm. Hmm. Hmm.
And this should return, so basically if it's on the right hand side,
Yeah.
okay, so that means when it reaches 0, depending on where it went,
Hmm.
it'll either become 0 or 1. Okay, so we are getting so this is it's go sorry, I'm sorry, I'm so sorry I'm troubling you like this.
No, no, no issue.
um so 1 second, let me just make the binary tree. 0 1 0 1 1 0. So what we are doing is, say we want this index, so we are
Hmm.
starting from here saying that okay fine, so we are starting saying that okay, it's on the left hand side.
Yeah.
So it's on
So
the left hand side. That means you do not need to go C by 2. You just go
yeah.
simply, you go simply here.
Hmm.
Over here, it is greater than C by 2. So you call the not,
Yeah.
and then it goes to 0. So returns 0, not of 0 is 1. So it
Hmm.
returns 1. So it goes like this.
Yeah.
Okay, I get it now. I'm so sorry.
Got it?
I
Yeah,
am
yeah, no.
so sorry though. Um, so this is basically the binary tree traversal in a
Definitely.
weird way.
Hmm.
Please tell me if I'm wrong. I won't take more of your time, but yeah, do tell me if I'm wrong. But if that's the right
No,
way
no,
to,
you are correct. This is the correct approach. Yeah. This is
okay,
the way.
missed that completely. Thanks a bunch.
Sure, sure, JB. You can India. Bye bye.
Bye bye. I didn't check if it worked though. I'm so bad. I should have checked it if it worked. Damn it! It did work. Well, I got the I got the thought process though. So I think I should be fine. We'll just toggle it. It's just toggling. Do I have to? Okay, I'm doing something wrong. I do not know what. That's kind of crazy. This should be easier though. Let's just play the music back though. Wait, am I wrong with the not operator? I think this is the not operator.
Well, did you ever feel lonely and you not know where to turn?
Yeah, we can
Did you ever
do
feel
that.
lonely and you not know
We can
where to turn?
surely do that.
Then you realize that you're paying the price for what you did, what you did to
Yeah,
her.
this time I'm not really doing this on my own, so I'm not. I'm gonna bookmark this question and come back to it again. For sure. If mid is equal to this, so mid is. Wait, what?
I'm awake every morning. I see the sunrise every day. I'm awake every morning. I see the sunrise every day.
Wait, hold on.
You know I never get no sleep at night. Not till the moonlight fades away. A little love from you, honey. That's all I ever really need.
That makes no sense. B is greater than C, C by 2. Um,
If you ask me to jump, baby, you know that I would fly.
that's crazy. Fuck it, copy paste.
Ask me to jump, baby, you know that I would fly. And if you ask me to shoot myself,
If this works, I'll be a little pissed because I did the same thing but only using an int.
I would surely die.
NK. Alright, the int. The int was the issue because I was not converting it to fuck. I was not converting it to int. I had to convert this freaking long into int and would have worked fine. The issue over here is b is equal to 1. B will never be equal to 1 until and unless I go ahead and say, hey, int c, and then we go ahead and say int this, and we go ahead and put int here, and fuck it, I'm wrong. I don't even know. Alright, we're good. We're coming back to this. We'll bookmark this for now. It's fine. We'll just bookmark this for now. We'll come back to it. How much time do I have? I think I've got another 30 minutes or so. We can do another question. It is 7:20 my time. We can probably do another question also. Yeah. I will one day go through all the bookmark questions, which will be an insanely fun day for sure. What should we do? Should we keep with the track and just do stacks and queues basics? Let's go do stacks basics. Let's do another stacks. Balance parentheses. Given an expression, given a expression string A, examine whether the pairs in the order, whether the pairs and in order of are correct. Okay, how many types of brackets can there be? Okay, so there are only 3 types of brackets. we can just do the same thing. We can just literally do the same thing. Let's just do that. We just replace it with a case. Alright, and C1, C2, C3, and n is equal to a dot length for int I is equal to 0, I is less than n, and I plus plus. We're gonna go ahead and do
Two women sitting at a bar.
a
Blind man
switch
playing on his guitar.
a dot character
Barcelona red,
at
it sounded
I.
blue.
So we'll just go ahead and say
Everything you
case
say, but I don't have you.
quote unquote
When you push love aside, you get the colors of the night.
C1 plus plus
Colors of the night, just one you.
break,
I'm in that place and time.
and then we're gonna go ahead and do this for every open case. Right, we'll do this, and we will do this. C1 plus plus, C2 plus plus, C3 plus plus. Let's just go ahead and go into all questions again. We go to the question that we just finished for this, and we can copy paste the code from there. That's fine. This is such a slow thing sometimes. Okay, all problems, balance parenthesis, where we did in Java, they supported Java 8 maybe? Yep. And we go ahead and say boom. Case. Should we make a helper function? Let's just create a return helper return int helper brax int count, and then we can just go ahead and say if count is less okay, this is not going to be much of a helper, isn't it? Yep. Okay, case, quote unquote, close bracket. I'll have to actually do this, won't I? I will actually have to do this. Oops, I did too many.
Give it up. When you push love aside, you get the colors of the night. And the colors of the night are just one hue. I'm in that place and time. Love's got its reasons and its rhymes. They say
We
you
got
are
that. We got that. We got
and I'm living
that.
in a world of just
C1,
one hue.
C2,
Everything is
C2,
because of
C3, C3,
living in the world without you.
and C2, C3,
Everything is
C1,
because of
C2,
I say
C3.
everything is
Why didn't I just use hash maps?
everything is
Like if set dot size is
ain't a thing I can do until
yeah, I don't know why I didn't just use hash maps. That's so stupid. I could have literally used set dot size and it would have been fine.
and wait
1, 2,
for you.
3, 1, 2, 3.
Wait,
Good.
wait for you. Everything is because of
If C1 is equal to 0 and C2 and C3.
for all you lovers
Actually-
in the house. I know we're full of lovers too in here.
If C1, C2, or C3 are not equal to 0, return 0, else return 1. Why is string a function? I know I should use stacks for this, but I'll get to it. I will cross that bridge when we come to what.
Come and find me. You always remind me that my gas gone. Yes, evening. I'm deeply under your power. Each minute
Wait,
seems
what?
like an hour since my galley's gone.
Whether the pairs of orders
Shadows fall
are correct.
off that wall. That's when I
Yeah.
need your loving most of all. What can I do? How can I go on? Take me
Wait. First of all, why am I doing it in Java? Bad one.
when the dawn is breaking. I don't want to waken. Since my galley gone.
Why am I doing the bad Java? I asked myself. open close. They have to be one after the other? Nope. No, they don't. No, they don't. Wait, hold on. What's going on? What the fish is going on? That's insane. Yo, hey Navneet, how's it going?
Yeah, fine. What about you?
Weird. I thought this was an easy question and I've somehow messed it up.
Okay.
Do you mind helping me out? This is a very weird situation. I know I'm not using the correct way to do it. I just wanted to get done with it, and I have, as you can see, not attended the class per se. It was just a simple stacks question. I guess I'm supposed to use the data type stacks, but I do not know why. Over here, what I did was simply just created cases, checked if they were less than 0, and just returned it if they were not. Like, that's all I did.
Given an expression, this examine whether the pair order are correct or not. Can we scroll down to the examples given in the problem? Let's scroll down. Okay, we have to return 1 or 0, right?
Yep.
Scroll up. What is your approach? Scroll up.
Just check if they add up. If not, and if they're less than 0, just return 0.
If they are 0 rather than 0, else C1 plus plus. Okay, but for this case, right, your conditions are not matched, right? Because all of your conditions are satisfied for this case, but still you don't have the correct answer. There is open bracket, then curly, then means parenthesis, then curly, then close parenthesis, then close curly bracket, right? It means all of your if and else are satisfied, but still the answer is incorrect.
Yeah, but why?
Yeah, because order matters. Okay, if first is parenthesis, then curly brace, so in the closing, the first should be curly brace, then parenthesis.
Okay, so I'll have to literally use a stack if not, if it won't work.
Right, exactly.
Fine. Okay, let's just take a. I'm guessing stack is the data type where you go. It should just be this, and I can do char.
Yeah.
Okay, and is equal to a dot length.
Yes.
Okay. So for, sorry, shoot, my bad. So we can. So am I just supposed to do int I is equal to 0, I is less than a dot length, I plus plus.
Hmm.
So if let's say
If it
a
is
dot
opening,
character at I is equal to quote unquote open braces,
then put it into the stack.
stack dot uh, push um, crap so can I not do or over here?
But you need to still check for each and every condition. Yeah, you can
Like
use or
so I
or
can use
and then
or over here, no? So
directly
if it doesn't matter whatever is pushed, right? It's when popping
right,
happens we get to know.
right.
Okay.
Hmm.
Um. Okay. Character dot push. Push. So we can just go or. So we can just get. Okay. Stack dot push a dot character at I. All right.
Hmm.
So then we can just
Okay.
do else stack uh,
Now check. Okay.
if stack dot top
Just check if stack is empty, return 0.
is
First of all, if stack is
sorry
empty, if stack is empty, or you can say size. If stack dot size is 0,
oh yeah, right, I didn't even think that.
stack dot size equal to 0, or 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 okay, if the top element doesn't match with my a dot character I.
Sorry, I don't know the syntax.
Stack dot top for Java. Peak.
Oh, peak. Is it peak?
You're right. Stack dot peak doesn't equal to a dot character I. No, return 0. Otherwise, pop the last element. Stack dot pop. Now at the end, return 1. If it is empty, if stack is empty, only then return 1. Otherwise, return. If is stack not empty, return 1.
Oh, sorry, I can just do this. This should fine.
No, yeah, run.
Huh?
Run it. Yes, run it.
Alright, stack should be capital S, and I'm guessing
It
yeah,
is
this
a
should be
name. It can be anything. Character CH. Spelling of character is wrong.
Is this it? This should be it, right?
Mm, yes. Int.
Why did I do this?
Parentheses.
Why did I do this?
Parentheses.
Why am I like
Yeah.
this? Uh, really? Okay, this should be fine now.
Hmm.
Templated stuff. Okay, wrong. Why?
Okay, scroll up.
When the flames of our flesh have stopped burning, And the fire of our love has cooled down.
Oh, yeah, of course. Tag.pk. Damn it.
Too many times I
What's the issue?
lost my
Of course it did not work. I'm so sorry. Yeah.
your loving.
So this has to be in a separate condition. Um,
Why?
yeah, because it will not be equal, right? It has to be the closing braces, not the opening braces.
Yeah, and I'm checking for the closing. Yes, I'm checking for the closing now.
No,
I'm in
because
the
no,
else condition.
in the peak, and you get the last character. Say the last character is square bracket. The next character is this
Hmm.
one, closing
Oh,
bracket. So how will closing bracket be equal to the
yeah.
opening bracket?
Yeah. You need to now check if and else, if and else, if and else.
Yeah, I don't think we need to like check if and else, right? Can I just not do? Let me just see. Um, what I can do is character t is equal to pop if uh,
You need to
oh,
use if and else. Okay, if top is this, then a of I should be this. If top of this, then a of I equal to this. If top of this equal to this, else return.
um, shit. If
T
God.
is equals
So
to
I'll have to
opening.
create a switch case, right? Switch case will be better. No,
Right.
if what is we can do swit
Just
switch.
write one single line. Okay, if everything goes well, it's correct. If none of the condition, if there is some error in any of the condition, return 0.
Yeah. So oops, one second. No, I'm confused. So sorry. I think the simplest one would be um,
if if
if
if t equal to yeah, if a dot size equal to opening parenthesis, then t should
yes,
be
exactly,
closing.
exactly. Switch switch t is wait switch is like this, no? T case quote and quiz quote unquote here um, then one second break, one second, we'll go control alt.
Yeah, don't use me as your fool.
Sorry
Break my
shift
heart.
You have to check the
yeah, there we go.
condition, no? Then
Okay,
I said, please don't use
so
me.
sorry if top okay,
is
so right
equal
now
to
what do we
this.
have
You need to check a dot character. A dot character I should be uh, t are the opening. In stack, I am only storing the opening parenthesis.
yeah, in stack you're only storing the opening parenthesis, no? So we can
Yes.
do, yeah, we can do T is the top, right? If
You are
character,
overcomplicating now. To be
no,
honest,
no,
you
no,
are
sorry. If
overcomplicating.
character I is equal to quote unquote opening brackets.
Character I is closing. T is opening.
All right.
Because in stack we are, it's opening. T is closing. Yeah, A is closing.
Um,
Yeah.
okay. If character at I is not equal to opening bracket, return 0, right?
Right.
Okay.
Don't use me
Okay,
as your fool.
so what does it do? It gets the pop, it'll get the opening element. If this is not equal to this, this is not equal to this, this is not equal to this, return 0
Why
0.
break? Why break? Break means you no need to check for the second condition.
Well,
Oh, right. Good call, good catch, good catch.
use me as your fool. You know my heart
Right.
can't stand
Okay.
another lie.
No,
Alright.
we do not, right? Because see, in the case it'll go like, oh, case, is this the case? Is this the case? Is this the case?
Right.
So it
So why are
doesn't.
you breaking?
So if we don't break, it will go check the next condition, right? So say if the top is
But
not
T is a constant, no? It will go to any of them. Why it would go to two conditions?
point. Okay,
Yeah, right.
I
Right.
think it should work, right?
Maybe.
This is always nice to hear, maybe. Okay, perfect. Why did this not work? So we had open, open, open. In the close bracket, we came if case is this. Nope, that's not the case. It should not go inside. If case is this, it should go inside and it'll say, hey, um, the top is equal to this. So yeah. Yeah, I think we need to put break because then it checked this as well. Yeah, 1 second.
Okay.
Because it checked this as well, no?
But okay, I don't use switch that much. Maybe you know better. Yeah.
Yeah.
Yeah. Perfect.
Wondering when I'm gonna open the door. Bringing back
Let's submit it again if submit button is working.
Okay, there we go. Thank you.
Okay.
That was very weird. Sorry about that. That was funny. That was funny though.
Yeah.
Look,
Okay. Bye.
that was weird as fuck. Do we do one more though? I think one more should be cool. We are at 1,000. One more should not be that bad.
driving that road.
Hmm. What's the time? If it's 8 o'clock, then no. We are nearly at 8 o'clock. Sorry about that. 1 second, need to check out the Snapchat.
Trying to get home quick as I can.
Oh, that is funny.
I gotta be up at 6 a.m. I'm trying
That is funny. That is absolutely funny. I have to give this to that chick. I'm not gonna explain anything to you.
well, I'm trying to make $1 or soon it will finally be end.
I'm happy I got to like at least do a 2-hour session today. I think that's one thing I'm gonna give myself. I'm just gonna unlock it. If I don't feel like doing it, I won't do it. I would have to a flattened nested iterator, which is medium difficulty for 50 points. That's so stupid. Why would they give me a medium difficulty for 50 points? Oh. What is this? This is supposed to be funny? For 50 points. You're given a nested list of integers. Integers, nested list. Each element is either an integer, the list whose element also may be an integer, or the list. Implement an iterator to flatten it. Example 1, nested list this. Output should be just
My heater don't work, forget my stove. The repo man come and took my coal.
oh god.
I'm trying to make $1 or soon it will
Okay.
follow the end. Well, I'm trying to make $1 or soon.
So we've got a nested iterator. Hmm. Okay. Okay. You should not implement it or speculate about its implementation. Okay, this is the interface that allows you to create a nested list. Okay, this is the nested list, nested iterator. Nested return. Okay, so you should. Okay, so this is just a constructor that will add a nested iterator with the whatever so and so. Return true if the nested integer holds a single integer rather than the nested in list rather than a nested list. So if is integer is true, um, true, you're good. Um, return a single integer that is nested, that this nested integer holds. If it holds a single integer, result is e to the power nested holds, but it returns the list this nested integer holds if the what is this supposed to be? Okay. All right. Okay. Fine. So we can go ahead and create a um,
I'd buy those people a place to stay.
named let's just call it list, man.
If I
Let's
had
just call it list.
money.
We'll say list is equal to nested list. So this is just a constructor, so we can just assign that it doesn't matter. Now we can go ahead and use list to kind of mess around with anything we want. Okay.
But all I got
If it has an integer, it'll return true. If it does not have an integer, whatever has a list. Okay.
and I got so little
So mm,
if I had faith.
return a single integer that this nested integer holds. If it holds a single integer,
If I
the result is 1 e to the power of 9 if the nested integer holds a nested list.
I'd get down on my knees.
Okay.
But all I got is bad religion.
Returns the list that is nested
Nowhere to pray.
if it holds a nested list. Okay. That is crazy. Alright. What is 10e9? Okay, I can just use 1e9, it's fine. So, Okay. Okay, I'm figuring this out slowly. This is not worth 50 points. This is stupid. This is absolutely stupid. Because I have to flatten the list. I've got three functions: is integer, get integer. So I'll probably use get integer as anything if possible. Um, so what I would rather prefer like flattening a new integer list here, like just flatten it completely here and just get next till it is just there. So I can write a flattened list over here and then just get next and has next, whatever. Um,
If I had magic,
how do you flatten a list though?
I'd clean up the whole mess.
Okay, let's say
If I had magic,
int n is equal to nested list dot size.
I'd clean up that
Okay.
awful mess.
For int I is equal to 0, I is less than n, I plus plus.
I'm just a working man, and I'm hoping for the best.
int
If I had money,
val is equal to can I write a function and can I write a recursive function for this actually? So like say if I have the nested list, okay? So say I can call it for whatever. So I can go ahead and say, hey, pass the result and the nested list. Okay. What I can do is, I can say result is equal to new array list. Like I can just return the result. Result is equal to new array list.
and I have to make a brand
And
new start.
yeah, I'm not doing this.
The blues has got me.
Fuck this right now. I'm out.